Okay, so today we're going to finish up the graphs of, the one-to-one functions, which is this, the homework. You guys have graphs of inverses and one-to-one functions. Looks like this, right? And then we're going to start in on linear functions. So we're going to enter linear functions today. We will also tackle linear models by hand. I don't know that we're going to get into linear regression, but we might. Today you have due in class vertical translation homework. So that one looks like, someone have theirs that they can show me?
Well, just lost in vertical translation.
Oh yeah, you're right, here it is. It looks like that.
Yeah.
So this one is due today. Make sure you get it in as soon as possible if you don't have it in today. There's like, lose like 1 point every couple days if you're late. Actually, probably 1 point every day because it's 20 points. It's not 20 points. So you lose 5%. As you start getting later and later, it's 5%, 10%, 15%. And then also today you have due the MyFM Math translation of functions. I feel like I might have shifted that. No, I didn't. I left that one alone. So make sure that you, have you all started on that? What to do today? Okay, any questions about that one? Okay, so remember the shift, if it's a vertical shift, it's on the outside, and you just add or subtract, right? If it's a horizontal shift along the along the x-axis, then it's on the inside, so it's right inside where x is. So you replace x with x minus whatever you want. So if it's right, it's x minus whatever you want. If you want to go left, it's x minus a negative, so it's x plus whatever you want to shift left. And I can, maybe I'll kind of just repeat that in a second. And then Monday you have composition and inverse functions, which we went over last class. And then next Wednesday you have in-class graphs of inverses and one-to-one functions. Next Friday, I'm also going to have you guys do the linear equations review. We're starting linear equations today. And then also the in-class linear models homework. Yep. Which we will probably hand out on Monday. Okay. I might shift some things around a little bit as we go. All right, so just a reminder, if it's a vertical shift, so f of x equals 2x minus 1. If I want to go up 2, I just add 2 at the end, right, and simplify. Horizontal shift, so here I have f of x plus 2x minus 1, and I want to go right 2, have to it would be 2, and inside here goes x minus 2. Right, it's on the inside, right where x is.
Yeah, and then you would distribute, like multiply out the 2
yeah,
times 2x and then 2 times minus 2.
Let me do this like it's going to be on your homework. Your homework is going to be like this. So then since this is more similar to what you're going to get in the homeworks, I give you more, just to kind of warm you up to the idea. So then since it's squared on top, you're just going to leave it alone.
Oh.
Because you don't want to go inside. You can't go inside if there's a 2 up here. There's a number up here, whether it's a fraction or a whole number, you can't go inside. You'd have to, figure out what this is first, and we're not gonna go there. So we'll just leave it as is. We'll keep it simple in this class. That's, we're giving you just kind of the basics of algebra, and we're not gonna, go to that spot, go to that depth. Okay, everybody all right with that part? Okay. So let's next pull out our graphs of inverses and one-to-one functions. And where we left off, so everyone has a sheet out, this one out, in the upper corner, the last thing we went over last class.
This is the homework, right?
Yes, it's the homework. Sorry, it's homework. And it is due Wednesday.
October 13th.
Thank you, October 13th. Perfect. So I'm just touching on some things, some basic ones. I'm just going to do like one problem with you guys so that you can, or part of a problem with you guys so you can do the rest of them on your own. And we've done most of these. Did we do this one yet?
No.
No? Okay. So you'll have,
Oh,
Well, yeah, we did that.
we did one. This
Yeah.
one, yeah.
It's not two.
exactly.
Yeah.
Right. So yeah, you guys gotta do 2 and 3 in your own homework, right? And then, let's do a little bit of review of inverses. So, previously we looked at graphs of relations and functions in the rectangular coordinate system. Do you remember, so basically you looked at graphs, right, the normal coordinate system. Do you remember what test we used to see if you're looking at a graph, if that function, if it's a function or relation?
The vertical line test.
Yeah, vertical line test. You guys remember we have this, we draw a vertical line, straight up and down, and we slide along it to see if it hits more than once, right? Right, we kind of move that around to see if it hits more than once. If it does, it's not a function. Vertical line test. It should hit only once. And by once we mean hit it in, so just grab it in your own words, sorry, my bad. So everyone write down in your own words what this should, give a few more, hit only once is sort of a very brief 3-letter, but write like a full sentence with a little more detail than what I just said. What does hit only once mean? What do you think? What do you think it means? Okay, pause until you finish this at home. So I'll let you guys sort of put that on your own, but but I've talked about this, right? That if you draw a vertical line, it should only hit that function one time. Okay? It should not hit more than once. So this one hits twice, this would be, right? This one is fails vertical line test. Anyone on board with that part? Okay, so we're going to move on. So, have I talked to you guys about one-to-one already, or not? Have we discussed the horizontal line test? No, okay. So, first question is this one a function or relation? I draw my vertical line. I'm going to move it around. Is there any spot where this line hits the graph more than once? Yeah, 2 spots actually. Here. Oops, can't get down there.
Oh, so you're not connecting the dots on these, I mean,
No.
as far as verse, and then putting that line test on there, because
No.
you don't know which way the dots connect.
Yeah, this is, dots are dots. Do not make this, don't change this graph.
Okay.
A dot is a dot.
Oh.
This is not the same as this. Here, this is all the function. Here, just boom, 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 boom. That's it. They're different. Everyone understand what I'm saying? So points are different than lines. And it's going to be, so here, that's a great question. So thanks for pointing this out. Here, my domain, heads up guys, this is important for the exam. My domain is just -3, -2, 0, 1, 2. That's it. Just those points. Over here, my domain is, it's all on here. -2, or sorry, I'll do this here, this is easier. Right, 2, 2.1, 2.2, 2.3, 2.4, 2.5, 2.3. It's every point between 2 and 3 as well. So it's not the same. Here it's just 2 and 1. Not 1.5, not 1.2, not everything between 1 and 2. Do you guys see the difference? Here it's everything along here as well. Everything between 2 and 3. So my domain here would be just points. Now what is this? A -3, comma, -2, comma, 0, comma, 1, comma, 2. Here, it's everything along the way. So this is, over here, it's a range, it's intervals, right? Everything from -infinity up to 1. Everything along there, right? Everything along there. Not just -2 and just -3 and just -1, right? It's everything in here. Here, no. It's not everything from 3 to -3 to 2 because look there's nothing here, there's nothing there, there's nothing in the in-between spot. Do you guys see what I'm saying? So that's how this is totally different.
On the right-hand side graph, wouldn't it be -infinity with
Yeah, and also,
infinity?
yeah, and then it would be also 1 to positive infinity.
Oh, okay, yeah, because the other
Yeah.
side, yeah.
Right, but so that's how these two are totally different. So I just want to make sure that as an interesting side note, that's one because people get lost on that a lot. It's super common, so I want to bring it up as often as I can. Okay. So I'll just put a little star. FYI. Right. Okay. So here, this one we would say it is not, right? This one, why? Because it fails a vertical line test. No. Oh, sorry. Not no. Relation fails. DLT. Incidentally, this one, oops. People have sort of tried to say, oh, but look, it's sort of touching it a couple of times, like there and there. No, no, no. When we touch it, we mean touch it, go away from it, and then come back to it. Do you know what I mean? So you'd have to touch it and then curl around and touch it again somewhere else. Not like right next to it. It's got to like touch it and then come away and then come back. That's what we mean by more than once. Because really, it's not quite the same. It looks like it is, but it's really just touching it once.
So it wouldn't count for the second set? Like, because that lower line will, if it goes to infinity, will eventually be able to touch the vertical line test.
Is not going to infinity.
Yeah, it looks like it,
It just goes straight down
right?
one.
So this one, yeah, so this is a little tricky. It gets closer and closer and closer,
Yeah.
but it doesn't ever actually touch one.
How
And this
is-
one goes upper and upper and never touches, never actually gets to this spot. It gets close and close to one, but never touches it.
And
How
then
would
it
you
just
tell
like
that? Because it's going, it's
It's going
easing
slightly.
over to the right, so eventually
Yeah.
it's gonna keep going.
Um,
How would you,
Well, think about it like
Because
if you have a value divided by 2, you divide it by 2, you divide it by 2, it keeps getting smaller, it never touches 0. That's kind of what's happening with that line. It keeps getting down that spot we're talking about. It keeps getting slightly bigger, but it never quite reaches that line.
no.
right, and I guess what he's saying is, how do I know, like, if you look at a parabola, it looks like it's going to the right and left forever and ever, and
Yeah.
that one does. And this one looks similar to a parabola to you, is what you're saying?
I don't know what a parabola is, but yeah,
It's
just the line
it's
looks,
that U-shaped thing
okay.
that you
The
guys are
line
seeing.
just looks like it's easing to the right a little bit, so if you go on for infinity, it's gonna eventually go to the right, keep going, you know.
So
or
for
go
now-
down, Yeah.
For now, you're just gonna have to accept my
Yeah.
statement that this one gets closer and closer to one and never touches it.
Okay.
And then, as we get into these, next chapter and the chapter after that, then you're gonna be like, oh, okay, now I see the difference. Does that make sense? But
Hmm.
it's sort of, I don't wanna get into those chapters to explain it to you
Right.
now. So for now, just accept it. Does that seem all right? Are you guys okay with? I'm telling you, this one gets closer and closer and one that doesn't touch it.
Okay.
Okay, and I'll let you know when they do. When you know, but this is, the only one that we really have right now is this sort of one that we'll have a couple in chapter 4, we'll have a couple in chapter 7. But they look like, this one looks like this is the first one.
Okay.
Yeah. Okay, so. So then, we talked about every function having an inverse, but sometimes the inverse of a function is not a function. So you guys remember we talked about how like every teacher teaches only one subject, right? So if you drop in a teacher, like you drop in me, I only teach math. But if you did the inverse and said, well, I'm going to drop in subjects and spit out what the teachers are, then if you drop in math, you're going to get more than one teacher. You'll have more than one answer. So it's not, the inverse would not be a function. So is everyone following what we're saying? So inverses, if you have a function, its inverse is not necessarily a function. Or you guys remember the candy machine, right? If I want to know how much a Snickers bar is, it's always going to be $1.25. But if I want to say, well, I have money, I want to spend $1.25, you might get Snickers, you might get Twix. It could have two different answers. So again, a function, its inverse is not always a function. What's up with inverses again? Remember, the x and the y swap, right? The inputs become the outputs become an input. So in other words, if 3 goes to 1, if 3 goes to 0, then the inverse 0 will go back to 3. Right? So if my function was subtract 3, everyone understand me? So my function was subtract 3, then I put in 3, I subtract 3, I get 0. The output would be 0. What's the inverse of plus 3?
-3.
Minus 3. So then an input of 0. Oh, what did I do? I said, did I say plus? Did I say plus?
Mhm.
Okay, sorry. You guys gotta stop me when I do something wrong. So if my function is subtract 3, 3 minus 3 is 0. Right? Okay, so now people are nodding like, okay, that makes sense. 3 minus 3 is 0. So the inverse would be 3 plus 3. So the inverse, 0 plus 3 would give me 3. So these two are inverses of each other, right? This is from the function take x and subtract 3. This is from the function take x and add 3. They undo each other. So that's if I started with 3, this one would give me 0. And then if I put it into the inverse, I get back to 3, which is what you expect. Right? Okay. So, good. So again, the reason for that is the x's and the y's should swap. They should undo each other. All right. So if you graph these, what you're going to notice is that there's a symmetry. And what you'll see is that these points, they're reflected from each other across the xy axis. For example, here is 2, 1. Its inverse clearly is 1, 2. Everybody is good with that, right? Because you swap the x and the y.
Yeah.
So 1, 2. Here's 1, 2. And you'll see they're reflected across this line. You would call this the vertical line. It goes directly through the, it's, I think it's a 45-degree angle, goes right through the origin, boom. That's the line y equals x. Y, y here, whatever x is, y is the same thing. Whatever if x is 2, y is 2. So that's this line y equals x. So what you're going to do with this one is you're going to do what I just did. Right, you're going to label a point, then you're going to swap the x and the y and graph the inverse point that goes with it. So you'll do that for all the other 1, 2, 3, 4, 5, 6 of them. The other 6. It will be very messy. Yeah. Yeah. Do your best to keep it as neat as you can. Maybe try to do.
Your purple pen. Okay.
Yeah, use a purple pen. Maybe do all the regular dots in pencil and all the regular dots in purple pen and do all of the inverses in pencil or something like that. That way you can erase them if you need to. And then what happens if you draw a line from? So when we draw a line, so then we'll have you guys let me draw lines, and what you're going to see is they're going to make these interesting little patterns that are reflected directly across this blue line here. It's very interesting. You'll see it when you do it.
Oh, you want to connect?
I'm sorry? Yeah, connecting. Yeah, connect the dot to its inverse. Connect that to its inverse. So I'll write that. If 3 is unclear, then right below 3 or next to 3, connect dot to its inverse. Okay, so make sure that you understand that that's what 3 is asking you to do. Those lines. Okay, you want me to write that down? All right. So what you end up with something that looks like this, right? And if you kind of look at other functions, for example, they'll look like that. So there's the original function, which is a line, and you see the dotted function, which is the inverse. So if you fold that page, you'll see their reflection right along. So if you literally fold the page right along that spot, right along this line here, you'll see that if you look at them, they lie right on top of each other. The reflections across that line.
For the reflected dots, we're supposed to use this open circle like this?
Oh, you could do that.
Okay, that's what they're showing.
Yeah, that's possible. That's another option. There's also some, or you can use different color pen. That's totally too. That works too. So for each of these ones, you're going to label the points. Wait. You're going to say whether or not it's a function or relation, and then sketch the inverse. And say whether the inverse is a function or relation. So here, I'm going to here's the easy way of doing this. Point by point, figure out what these points are. Figure out what these points are. You label them. And then, you know what the point is, like this point is 1, 4. And I know its inverse must be 4, 1. Here this one is 2, 2. Its inverse must be 2, 2. And then draw a line between them. And what you'll find is, this is, what is this one? -2, 0. So its inverse must be 0, -2. Draw a line between them. Which one? This one. Wait, which one? 2 goes to this one. And then figure out, make sure you draw them before you, before you lose track of which one matches up with which one, or else you're going to get something strange. This one is -3, 2, so its inverse would be 2, -3.
What it tells you to, if you have the graph with the function or relations, you only put in, you put in the lines or just the points, the shape.
Is the line. That's the whole graph. So the graph is the whole line.
Oh.
Yeah, the graph is the whole line. So this one, we would say it fails, right?
Totally different.
Right? Yeah. And I can make that something brighter, like hot pink. Right, so you can totally see it fails. Fails. The VLT. So then, what you're going to do is you're going to do a couple things. You're going to say whether the original graph passes the vertical line test, and then also say whether its inverse passes the vertical line test, right? So then I would go over here and I'd say, oh, if I move this guy over, the pink line over, oh, this also totally fails the vertical line test, right? So then the inverse fails the VLT also. Everybody kind of, what is this one? So then, if it fails the VLT, then it's a relation, right? Relation. The original one is also relation. So that's, you're going to kind of put those into their respective spots. So first you're going to say whether the original one is a, you're going to do the vertical line test, say whether it's a function or relation, and then you're going to sketch the inverse, and then you're going to say whether the inverse is a function or relation. Good? All right, so you're going to be doing that for, and this one's going to look something like, this one's a heads up. This other one here is going to look something like that. You should get something that looks like that, sort of. Not quite, but something, along those lines. And then you'll do the same thing. You're going to get some interesting. They're kind of cool. As a hint, this one, I might also graph this point up here at the very edge, just to kind of help you figure out how this line goes, because people get confused about how it attaches. And they keep trying to do like this sort of thing or something like that. They keep trying to do something strange with it. So to avoid doing something weird with it, I would also just graph, just kind of roughly, and you can say, oh, that's like 2.5 or 2 1/4, whatever you think, right? I'd graph those very, very end ones, because otherwise it gets hard to know where it should go off the page. Right, so then you gotta figure out which ones were both the original function and the second one both functions. So then we're gonna talk about, some more stuff about one-on-one functions. One-on-one functions. Okay. So, we're on page, what is this? Well, yeah, so, I need a reader for this part. The one-to-one function part, where it says one-to-one functions. Eric, go ahead. Right here.
When
When
is
is,
the inverse of a function also a function? Only in a special case, when the function is one-to-one. The function is one-to-one. A function is one-to-one, there is exactly one x value associated with each y value. Or another way to put it, if the ordered pair lies on the graph, then no other x can be paired with y, I don't know what that is, y1.
yeah, so I'll give you a couple examples.
On
So
the-
this one, every x has only one y, but every y only has one x. They're one-to-one. They both only have one. They're kind of monogamous, think of it like that way, right? So here, this x has only one y, this x only has one y, but they share the same y. This y has two x's. That's not one-to-one. Over here, every x has only one y, every y only has one x, so it's one-to-one, right? He only has one, he only has one. So it's one and then to one. Do you understand? So it's here, it's like 1 to 2. This guy has two options, right? So he's saying, well, I only have you. And he's like, well, I don't have only you. I've got two people. Whereas this guy says, I only have you, and says, oh yeah, I only have you too. Everybody